It's evening. You have put on some music to relax, you have plugged your phone to charge at the other end of the room, and you are trying to rest. There is a high probability that either of these two factors will suddenly disturb your peace of mind. First, the music is playing too loud, and second, a song you hate is playing. Luckily, you have this device with which you can have tremendous power over the music you play. Oh, you don't? Seriously, you will need it. Surely you are curious how I made this wonderful project. I started with a prototype, breadboard, Node MCU, RGB diode and gyroscope. Somewhere on the internet I found an article about connecting Spotify with ESP32, and based on it I created a code that controls the music through the current position of the gyroscope and turns on the appropriate color of the diode. After tens of thousands of edits, the prototype looked like this. Which is pretty good. Time to transfer this layout to the schematic and PCB design. Here is the diagram I designed. Now I have a question for you. Why did I connect the SDA and SCL pins to some two pins that have absolutely nothing to do with I2C? You don't know? Then I will tell you. Because mistakes happens even to the best. And because I am the best, it happens to me always. Maybe that's why I made a similar mistake with the gyroscope. Okay, let's move on. Here is a circular PCB design with a diameter of 40 mm. If I would throw out the ESP12 module, I could significantly reduce its size. On the left side, there are two small diodes indicating if the battery is charged, RGB LED indicating the change of the gyroscope position, which is on the bottom side of the PCB, and on the right side there is a cutout for the USB Type-C socket. Then I uploaded the Gerber files to the PCBWay website, clicked a bit and ordered the PCBs, and then moved on to soldering them. Due to the large number of elements to be soldered, I decided to use the hotter station, but the needle that I used to spread the paste was not usable because this paste dried in it, so I applied the paste without it. I collected the excess tin with a braid and cleaned up the flux residue with isopropyl alcohol, and I confidently say this PCB looks pretty good, and most importantly, it works. At least the charging section. I made the last corrections to the program and uploaded it to Node MCU, then desoldered the Wi-Fi module and soldered it to my device. It was only at this point that I realized how many mistakes I made while designing, and it took me a long time to correct them. But it works. The last thing was to print the case.